All right, so what we're looking at is something called the average rate of change, right? And it looks a lot more complicated than what it really is, right? Because the average rate of change is simply the slope. It's the slope between 2 points, okay? So let me draw your attention here, because what you have up at the top is all of this extra information about for the function f of x, right? So some function between x equals a and x equals b, that just means between two different values on the x-axis, right? The average rate of change is change in y over change in x. If you look at that formula, it's probably not too familiar because the way that we used to teach it back in Algebra 1 is y2 minus y1 all over x2 minus x1. All right. So this diagram that you have here, I'm going to give you a very similar one that is probably a little bit more familiar because I'm going to try to use the notation from slope that you learned in the past. All right. This one is one that you see more in like pre-calc and calc, but I want to draw that other one so you make the connection between how these two are just talking about slope, right? It's just a slope. All right. So average rate of change is the slope of a secant line. Okay, a secant line is simply a line that connects between 2 points that are already on the graph. Okay, so if you look at the diagram, you can see how there is a line right here in dashed that is connecting this point and this point, right? So when they're trying to find average rate of change, they're just simply looking for the slope between those 2 points. Okay, that's literally all it is. So a lot of what this lesson is just finding slope. Okay, so let me draw a very similar picture before we get to the example. All right. So your you have your xy. Okay, I'm going to draw a curve through it, similar to the one that we have above. Something like this. Okay. And you want to find the average rate of change between two different points on that line. Okay. Yes, this would be a good one to draw because I want you to make the comparison between the notation that you're probably more familiar with and then all of this new notation. Okay. So if I wanted to find the average rate of change, okay, another way to see average rate of change is slope formula, right? What is the slope formula? Slope formula, the one that you're familiar with maybe from Algebra 1, would be y2 minus y1, x2 minus x1, right? I hope that that's familiar, right? Because that's what you were taught back in, whenever you took Algebra 1. Okay. So you'll notice how a lot of this is really talking about the same thing. All right. So whatever A is, well, let's say these are the 2 points that I'm talking about. It can be any 2 points on the curve, but we're just going to use these two for now. Right. So this first point down here, this would be my x1, right? Or my first x, right? The one is just notation. So it's not like a multiplier. It's not an exponent. It's not anything. It's just an identifier. This is the first x. Okay. This other point over here is my second x. So what do we call that? That's x2. All right. So you have x1 and x2, right? Okay. Now, on the y-axis, right? On the y-axis, typically, right, you would say, okay, well then if I go across this way, this would be my y1. All right, that's my y1. However, we've grown a little bit more sophisticated since Algebra 1, and now we're using function notation quite a lot, right? So rather than calling it y1, what's another way to say f of x? I'm sorry, what I gave it away. What's another way to say y? It's f of x, right? But instead we would call it f of x1, right? It's the output when we have x1 as our input, right? So notice that these two things are basically the same, right? It's the same. Y1 is the same thing as f of x1, right? F of x1, not f of 1, f of x1, right? The x1 is the input, right? So that has to match my input. And then up here, this would be y2, right? Let's say we were still back in algebra 1, it'd be y2. But because we're in algebra 2 now, and we're using function notation, what would I call it instead? I wouldn't use y2 anymore. I would use what? Yeah, f of x2, right? F of x2, that's it, right? So these are just notations, right? These are just notations. So look at how your slope formula, right? It's gonna change a little bit, right? Because we're not using y2 and y1 anymore. We're using f of x2 and f of x1, but they still mean the same thing as y2 and y1, right? So now you have a new slope formula called f of x2 minus f of x1 all over x2 minus x1, right? So the bottom didn't change, but the numerator did, okay? All right. Now, why do I show you that? Because then that one helps make a little more sense to the one that you see above, okay? Think of A as x1 and think of B as x2, right? So now imagine in the formula here, instead of B, that's x2, and instead of A, that's x1, right? So your denominator is just x2 minus x1, right? All they've done is that they've switched it to other letters, right? Instead of calling it x1, they call it A. Instead of calling it x2, they call it B, right? But look at my denominator. It's the same thing as what I have in my slope formula, okay? Then look at this value right here, right? Instead of f of A, well, we know A is x1, so that's f of x1. And instead of B, well, we know B is x2, that's f of x2, right? So if I make the changes up here, f of x2 minus f of x1, right? So the numerator is just y2 minus y1. That's it. It's just the change in y, right? It's the change in y all over x2 minus x1. What they've done is they've just written it in a different way, okay? And that's literally all it is. So what is it that this formula gives us? It gives us the slope between these 2 points, right? So what is the slope? Well, the slope is, it's just the rise over the run connecting these 2 points. I can't even get this straight. Let's see. Right? It's the slope of this line, right? It's the slope of the blue line between the first point on the curve and the second point on the curve. That's all it is, okay? It's the average rate of change, okay? It's just a slope. So now you have basically 3 different representations of the same thing. You have your familiar slope formula from algebra 1, a slightly tweaked one, algebra 2, because we use function notation now instead of XY notation. And then you have this new one, which you need to get familiar with because this is what you'll see in pre-calc, which is using f of A, f of B, A and B. But this formula here means the exact same thing as this one, which means the exact same thing as this one, right? They're all the same formula. It's just different way of looking at it, all right? But I wanted to take you through this process of y2, y1, f of x2, f of x1 to show you what f of b really is. F of b is just the y value for that point. F of a is just the y value for this point, okay? So you get to kind of internally, you get to decide which one of those 3 makes the most sense to you, and that's the one you're going to use, all right? Because that's what your, that's how you need to picture it, okay? But ultimately, all that we're doing is finding slope between 2 points, AKA average rate of change, all right? So the slope between 2 points is the average rate of change. Any questions on the notation so far? All right. So now let's use it a little bit, right? And why do we find average rates of change? Okay. Well, let's talk a little bit about what average rate of change is in like kind of everyday normal conversation. Let's say you go, let's say you go to the store, right? You drive to the store. Maybe your car is parked in the driveway, right? So initially you back up, you go down the street. Maybe the street is a little bit of a slower speed limit. Then you turn on the main road, right? Maybe it's Atlantic or Slauson, and those streets are moving a little bit faster than like 57th Street, right? So those streets, you're going a little bit faster than you were before, but at every kind of interval of time, it's a different speed, right? But you say, oh, it takes me like 10 minutes to get to the store, right? Well, what would the average maybe speed be during those 10 minutes? Well, it couldn't always be like 40 miles an hour, right? Because that maybe was only the piece that you were on Slauson, right? But when you were driving down 57th, you were going 25, right? But overall, what was your average speed from the time you left your house and the time you got to the store, right? That would tell us your average rate of change, right? Your average speed during the trip. But different parts of the trip, you were either going faster or you were going slower, right? So what we're trying to do is like narrow down like, okay, between this point in time and this point in time, how fast were you going then? And then how about between this point in time and that point in time? How fast were you going then? Right. And so you got to think of like average rate of change as like speed. Most of the time it's like a speed. How fast was I going between these two periods of time? Okay. And so that's what some of these graphs, they don't really have any units, but that's how you want to think about it. My slope is basically my speed, right? But my speed as an average between a certain point in time and a second point in time. Okay. Right. You're not. This is, they use this type of stuff when they try to see if somebody was actually speeding without a radar gun. They can use it by finding out, right, how much distance did that person travel, right? How long did it take them to get from this point to that point? And if they were blown way over an average speed limit, then we know that they must have been moving faster than the speed limit. So this is sometimes how, it doesn't happen often, but sometimes it can track, right? Okay, so let's think about this first example here, right? So it's asking us compute the average rate of change from A to B, right? So we're going to focus specifically just on A to B first, okay? So we're going to go from here to there, right? From A to B, right? Now you can see that it almost looks like a straight line, right? But there's a little bit of a curve in it, right? So we need to calculate what is that average rate of change, right? What is the average rate of change? And if I want to find average rate of change, then I know I got some formulas I can work with, right? It's my slope, right? So my average rate of change, all right, from A to B. So if I did want to find the average rate of change between those 2 points, okay, what could I label these points as? Let's start with A, right? If I wanted to label these points, what could I label them as? And you can look back at my bottom picture. I can't label it AB, no, no. I have to use like X1, F of X1, X2, F of X2. Right? A is my first point, right? That's my first point. So this could be X1, right? Technically X1, Y1, right? X1, Y1, but we're not using Y anymore. So this would be X1, comma, f of x2. I'm sorry, f of x1, sorry. Okay. And then for b, this would be x2 f of x2. Okay. So why do I label it like that? Because I want to be familiar with this notation where my average rate of change will be f of x2 minus f of x1 all over x2 minus x1. All right, and then I can just substitute and plug in my values where I need to. All right, so f of x2, what is f of x2? Well, f of x2 is 9, right? So what I have is 9 minus f of x1 is just 3. Okay, my x2, that's 6. And then my x1 is also 3, right? So we can calculate average rate of change by labeling our points x1, f of x1, x2, f of x2. And the result would be 6 over 3. So then our average rate of change between point A and point B is just 2. 2 over 1, yeah, or just 2. We're not using C because we weren't asked to calculate the slope for C yet. Okay, the question was only the average rate of change between A and B, or big A and big B. Right, so this was our first one, from A to B. All right, any questions so far? No, what you're finding is average rate of change, right? So slope is the way that you think about it, but it is average rate of change. So moving forward, you don't want to call it the slope, right? It's just the average rate of change. So you got to change a little bit of like your language here. Okay, let's do the next pair, right? Now they want us to find from B to C, right? So it's a shorter span, right? Average rate of change for 3 points? No, it's only between 2 points. So take a look, right? The first time it's asking us to go from A to B, then it asks to go from B to C, and then the last one is from A to C, right? So we do the short one, A to B, then B to C, and then they want to see what's the average rate of change for the points furthest away. Okay, so, but they never ask average rate of change of 3 points because that's not possible. It has to be only between 2 points. All right, so let's take a look. Average rate of change. All right, f of x2 minus f of x1 all over x2 minus x1. Okay, but this time, because we're dealing with B to C, we have to relabel our x1 and x2, f of x1, f of x2. Okay, because now you're using a different pair of points, right? So then this, we're going to basically start over, right? So now B is my first point. This will be my x1, f of x1. And C will be my x2, f of x2. Okay. Does that make sense why we're shifting? Because now we have a new set of points. So I have to relabel everything to match what this question is asking of us. Okay. So let's go ahead and plug it in. Let's find out what this rate of change will be. Right. So f of x2, that's 11.2. minus f of x1, that's 9. x2 is 9, and x1 is 6. Okay, so it looks like I'm going to get 11.2 minus 9, that's about 2.2. And 9 over 6 is 3. Okay, let's see if we can get this average rate of change to be like one value, right? We have 2.2 over 3. If we divide that, what should we get? Yeah, it's about 0.733 with a repeating decimal. So we can do 0.73 with a bar over the 3 to indicate that it continues repeating. All right, so our average rate of change is 0.73. All right, so again, think about speed, right? Think about speed. Were you going faster between the interval A to B or faster between the interval B to C? Yeah, A to B. How do you know? It's a larger number. Exactly, right? The bigger the slope, the faster you're going. Remember that your rate of change is representing a speed, right? So 2, you're going faster than if you're going 0.73. All right, 0.73 is smaller than 2. So the 2 would be the faster rate of change. Right? There was more growth, vertical growth happening between A to B than there was between B to C. Right? Remember that slope is, or rate of change is change in Y over change in X. So there was a bigger change in Y over that 3-part period, over the 3 space between 3 to 6, than there was between B and C. Okay, so far it looks like from A to B, that's been the bigger rate of change. All right, and then finally, from A to C, right? From A to C. So that requires us to relabel one last time, all right? Because now I have A as my first value and C as my last. So A would then represent x1 and f of x1. And then C would be x2 and f of x2. Okay, so average rate of change from A to C this time, f of x2 minus f of x1. All right, let's plug in and let's find out the rate of change between A and C. All right, so f of x2 was 11.2. F of x1 is 3. x2 is 9. And x1 is 3. So 11.2 minus 3, that's about 8.2. 9 minus 3, that's 6. All right, let's try to get one number out of this, right? So that we can truly compare to see which one had the largest average rate of change. 8.2 divided by 6 gives us 1.36 with a repeating 6. Okay, so make sure that you draw the line over the 6 to indicate that it continues. All right, so for each 2 points, we had a different rate of change, right? So that's what I meant about like your trip to the store, right? You might start off kind of slow, maybe backing out of the driveway or just pulling out, right? So that first initial part of the trip is pretty slow. Then there's a part of the trip where maybe you're moving a lot faster because it's a faster road, or maybe it's a highway, right? Maybe you get off a highway on the off ramp, so you have to slow down. Maybe you come to a complete stop. And then you drive into the parking lot and you're going a little bit slower than you were even on the street, right? You can see how that plays out in multiple stages, right? Different points in time, different intervals of time where you are not moving at the same speed the whole time. But there's small intervals where you are moving faster than others, right? So take a look at the average rate of change from A to C, right? That would represent this slope right here, right? The line between these 2 points, okay? That line is not as steep as the one between A and B, right? Look how much steeper the blue line is, all right? And then compare that one to the slope of this line, right? So you have 3 different lines. All of them have different slopes, right? Different rates of change. But the fastest interval was between A and B, right? So that's what average rate of change helps us find, right? How fast were you going on average, right? The full trip, maybe from A to C, or how fast were you going on average just between A and B, right? And we can narrow down specifically what is the average rate of change between any particular time or on any interval of a given graph. All right, but the calculation component is rather simple. It's just your slope formula, okay? Any questions so far on how to identify your points, how to plug them in, how to solve for a slope? Okay, so you're gonna be asked these average rate of change questions in many, many ways. In one of them, this is the first case where they tell you, find the average rate of change from point A to point B, B to C, and A to C. Okay, that's just one example of how you'll see it, all right? I'm gonna scroll down to the next page. I'm gonna show you a different way in which it'll appear, okay? So let's move down, all right? And here we are at page 2. And I know this says note 16, ignore that. That was a typo, right? It's note 17. Okay, so now notice that there's a few dots all over this. Look at the function that we have, right? X squared minus 4. So we have a quadratic function, all right? And now look at the way you're being asked, right? It says find the average rate of change of the function from x negative 2 to x being 0, right? Where x is at negative 2 to when x is 0, okay? So then I'm looking for these 2 points, right? I'm kind of thinking as this as like, this is point A, this is point B, right? So when x is negative 2, what point is that? Well, that's right here. When x is 0, what is that point? That's this point right here, okay? So you see, I'm asking you the same type of question, but in a different way, because now I'm giving you the x values, right? Find the average rate of change from this x value to this other x value, right? So I got to locate the points, right? When x is negative 2, I'm right here, I'm on the x-axis. But when x is 0, I got to go down to meet the graph at negative 4. So those are the 2 points that I'm talking about. Why does it say average rate of change of f of x is equal to x squared? You mean this part here? That's the function that we're working with. So on the one above, we didn't have a function, we just had a curve, right? This time I'm specifically giving you the function. The function is x squared minus 4. All right, because sometimes you're going to be given the function without the graph. So you're not going to have a picture to work with. You're going to have to then be able to know, like, what does this graph look like, or how can I use that function to help me find my output, right? Right now, we can see the output right from the graph, but other times you won't. All right. So like I said, these average rates of change problem are thrown at you in just a bunch of combinations of different ways. So that's why I want to take you through like each one. Okay. So let's find the average rate of change between the 2 points that we have, right? I'm calling it A and B for now, all right, because it's similar to what we saw above, okay? But that's where I was able to find those 2 points. So I'm looking for a slope, the average rate of change between these two right there, okay? All right, now we could use the slope formula, all right? What's another way that we could find the slope between those 2 points? Much easier, especially because you have the graph. Rise and run, right? Sometimes you don't even have to use the algebra, just count, exactly, count spaces. So remember, slope is still rise over run. All right, so remember, you're thinking back even a simpler version of slope. But if I'm going to rise, I'm technically not rising. I mean, I'm rising, but I'm rising in the negative direction because I'm going from point A to point B, right? So I would need to go, sorry, I would need to go down 1, 2, 3, 4. So my rise is -4. And what's my run? +2. So what's the average rate of change? It's -2. So what does that indicate? If a slope is -2, yeah, average rate of change is -2. What else does it indicate? Is there a way the two can ever be negative? What do you mean by that? Well, slope can be positive or it can be negative. If a slope is positive, that means something was increasing. If a slope is negative, what does that mean? It's decreasing, right? So maybe I was slowing down, right? Maybe I'm slowing down at -2, or maybe I'm going backwards at 2 miles an hour, right? The negative indicates something different is happening, right? You're not moving, maybe you're not moving forward necessarily, or you're slowing down. Okay, and so when you get to physics, a lot of that will make more sense because you're talking about motion, right? For math, we're just kind of looking at it with that in abstraction. All right. Okay, let's take a look at part B now. All right, and let's identify which points we're going to need. All right, so we're still function, same function. We're looking at from x at 0 to x at 3, right? So when x is 0, what's that point? Well, it's way down here at -4. When x is 3, what is the point? It's up here at +5, right? So now we're looking at an average rate of change for a little bit longer piece of time, right? From 0 all the way to 3, right? But you see, it's a bigger vertical climb, right? Much bigger than what we had previously. So what we're looking for now is the slope of the secant line, which connects these 2 points. Oops, messed that up. Right, slope of the secant line between those 2 points. And again, we have a graph, so no need to go and do all this algebra. What can we do instead? Yeah, rise over run, right? So rise over run, let's just count our spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So my rise in this situation, which again is just f of x2 minus f of x1 over x2 minus x1. Without having to do any algebra, we know that that rise was 9 units. And then the run is 1, 2, 3. Right? So the slope of this secant line, 9 over 3, is just 3. Okay. Not terrible, right? It's a lot more simple than what it looks like initially, right? Okay. And then finally, the last interval. The last interval is from 0 to 2. Okay, so when x is 0, this would be the point. When x is 2, the point would be here. All right, so we want to find the slope of the secant line between these 2 points. All right, and once again, we're using the tool that we have, which is the graph. So since we have those points, let's just count, right? We're looking for the rise over the run. So guess what? Let's just count. 1, 2, 3, 4. It's a rise now vertical, right? Now you're going up 4, and then you're going to run 2. So now you have a slope of 2. Okay. Any questions so far on parts A, B, or C? All right. And then you see there's another question over here that asks, during which interval is the rate of change the largest? When is it the smallest? Okay. Could you tell me which interval the rate of change is the largest? Let me address a couple questions. So when it goes up or down, yes, that's the numerator count. Yeah, that's your rise. Right? Could be positive up or negative if it's going down. Why did I use rise over run on this page and not on the first one? Because here I can actually count. I can count the spaces. It was easier to count the spaces here. It wasn't as easy to count the spaces up above. All right. And I wanted to get you used to the formulas. Right. But I also want to show you that you don't always have to use the formulas. If you have it printed and the graph is nice with the X and the Y axis, right? You can use your knowledge of slope to just count rise over run, right? That won't always be an option, right? Rise over run won't always be an option, okay? But it's a useful tool. Right? Because with average rate of change and with graphs, there's so many ways you can look at the problem, right? There's more ways, there's more correct ways than just one. Okay, so speaking of which interval has the largest rate of change, right? You guys mentioned which interval would that be? We have 3 options. It goes from -2 to 0, from 0 to 3, or from 0 to 2. All right, so B, right? Part B, it looks like that interval had the largest rate of change. How do we know? Right? That's the largest slope, right? It's the largest slope. So that means that the change, right? The average rate of change was the greatest between that interval, right? Largest slope. So when they ask for the interval, it also means literally interval notation, right? What was the interval? Well, what was my X value where I started and what was the X value when I ended? What is that interval? 0 to 3, right? So for largest, it's 0 comma 3. How do I define, what do I use around those values? Remember, it's interval notation. Well, I have to include 0 because that's how I got that output value. And I have to include 3 because that's how I got that output value, right? So we have to use these brackets. Okay, so the interval right there where I had the largest slope was between 0 and 3. That was my interval. Okay. All right. And then trick question, which one was the smallest rate of change? Right. Some of you are saying maybe just A. What about maybe both, right? The interval where with A and the interval with C. What's the only difference between them? Right. But is the rate of change like smaller? What does the negative kind of indicate? It's the negative just indicates it's decreasing at that speed. The other one is increasing at that speed, right? But if you're thinking of speed, right, they're both 2. It's just one's decreasing, the other one's increasing, right? So it could be right, one slowing down at that speed, one is right. So when it comes to like when it's asking like which one is like the smallest, right, or the lowest rate of change, it's actually going to be both, like both. -2 and 2 are the same rate of change. It's just that one of them is in one direction and the other one is in the other, right? One is going down, the other one's going up. Okay, so you would list both of the intervals, right? So for A, what's that interval? It's -2, 0, all right, and 0 to 2, right? They both have the rate of change of 2. The negative or the positive is irrelevant. That just tells you direction, right? But the speed of somebody going down a hill or the speed of a person going up a hill and they're both going at 2, right? It's the same rate of change, same speed. Right, yes. When you're talking about these intervals on these rate of change problems, you'll be using the brackets, yes. I'm not sure I understand your question. Um, your interval is only talking about x1 and x2. That's what the interval dictates. It doesn't use the y values. We will always be using brackets. I think her question was like, do we use y values for your interval? No, you only use your x as your interval. It's almost like domain. Only the x values. Where it starts on the x-axis, where it ends. So the plus and the minus matter, but not when we're asking which one is the larger rate of change. Because if they're both 2, right, if they're both the value 2, but one's positive, one's negative, the rate of change is the same. The negative indicates direction. So in that case, like they're both the smallest, right? It's where the rate of change is the smallest because they're both at a rate of change of 2. It's just that one is in a decreasing and the other one is an increasing. So I hope that makes a little bit of sense there.